We're here with our Chemistry TV newscast with here Santos Quintanilla going to explain what exactly is light. So we'll take it over to Mr. Quintanilla. So Santos, tell me, what is light?
Well, light is both a particle and wave.
Okay.
Yes.
All right. And can you give me like examples of that?
Yeah. An example of light is, well, there's 4 examples. There is visible light. There's X-ray lights.
All right.
There are ultraviolet lights, and there's also microwave lights.
Okay, I have a light in my microwave.
Oh.
And can you give me some characteristics of that light?
Yes. Actually, all of the lights have different frequencies and different wavelengths.
Okay.
You see, the larger the frequency, or the wavelength, the smaller the frequency.
Okay.
The smaller the wavelength, the bigger the frequency.
All right. Now we'll move on. Now I'm just going to ask you a little bit about the electromagnetic spectrum. And so, what kinds of radiation have long wavelengths, like you explained? Like, what would be an example of that light?
All right. Well, example of it, the radio waves have a very long wavelength.
Okay.
And then it goes down to all the way to the gamma rays, which have a shorter wavelength.
Okay. So after radio becomes microwave, then infrared,
Exactly.
then your visible light, ultraviolet, X-ray, down to the gamma rays, like you said. Okay, great.
Exactly.
And what about the lowest frequency with that? We mentioned wavelength, but what has the lowest frequency?
Radio waves have the lowest frequency here.
Okay, that would make sense since they have the highest wavelength.
Exactly.
All right. Now, which radiations can be seen by the eye?
The ones that can be seen by the eye are visible spectrum.
Makes sense. Okay. And,
Sorry, I don't have my glasses on today.
hey, it happens. Can you give me, like, the visible light in order from shortest to longest?
Sure. So the shortest one is violet.
Okay.
It moves up to blue. And it goes up to green, then to yellow, orange, and then finally red.
Okay, great. Now, give me a sequence of the types of radiation from lowest frequency to the highest frequency.
Okay. So the lowest frequency starts off with the radio. Then it moves up to microwave, infrared, violet light, visible light, UV light, X-ray light, and then finally the last one is gamma rays.
All right, excellent. Now, can you give me a little comparison of wavelengths? Or compare the wavelength and frequencies of each kind of wave. What is the relationship between this? Or you can give me the equation.
Well, the equation is wavelength times the wavelength times the frequency, and then it will equal your constant.
Okay. And now I also wanted to know, how would you calculate this type of stuff? Like, what would you do? And for that, we'll move on to Mr. Nofziger.
Yes, we'll move on to Mr. Nofziger with this. All right, Mr.
Well,
Nofziger.
in calculating your wavelength and frequency, you would first probably given your nanometers, which you'd want to convert then to meters, so you have equal units. After you do that, you will plug in your wavelength, or if you're given frequency, you'll plug that in. And then you'll have to divide over that to the constant, which is always 3 times 10 to the 8th meters per second. And after you do that, you will then get the answer in your either wavelength or frequency, whatever it may be. And that final answer will be in hertz. Okay?
Very interesting.
So we're going to move on to now an explanation of the Hog Hilton.
All right. We'll stay
Not
on.
necessarily the Hog Hilton, just...
We'll stay on to Bird Nofziger for this one.
Okay, and what we're going to be doing for this, in this section of the newscast, is I will be explaining electron configurations and also noble gas configurations.
Okay.
So each like period table, everything on the periodic table are grouped into different levels of energy. For example, your 1s would be your hydrogen, your helium. Your 2s would move down. I should probably have a periodic table with me.
Yes.
so I can explain this.
I wasn't be
We'll
prepared.
have a brief pause as Santos gives you a commercial.
Yo, this is your homeboy. And no. Yeah, that's my rap. Go worldwide with that.
And we're back. Okay. Then after your hydrogen and helium, you would then have your 2s, which would be your lithium and beryllium. Then it would move over to your 2p, which has 6 different elements, would be boron, carbon, nitrogen, oxygen, fluorine, and neon. Now, as it goes on the same type of pattern until you get to the Ds, which looks like they're in the period 4, but in reality, they're a period below what they actually look like. So 3D would be, your row of Ds that looks like it's in the period 4 is actually in the 3rd period. So to draw this, you will have a line representing your first energy level. And we can put a 1s since it's in the s orbital.
Okay.
And like we said before, there's 1 electron in this, but it goes 2 different ways. So 1 goes up, 1 goes down.
Interesting.
You move on then to your 2s, which has your 2 elements and your 2 electrons, which also go up and down. Now, like I said, we move on to our row of 2p, which has go up. You always want to go one at a time, and then we'll go down.
So if I get this right, you want to stay in that direction when you're going across the line.
Correct. You don't want to skip down, or else that violates a principle that you cannot violate.
All right.
And then, after 2p, you'll continue down. You have your, well, that's too long, way too long.
Yeah, way too long, man.
We're on 3s.
Yeah, 3S.
3s is the next energy level.
Mm-hmm.
That also has 1 going up and 1 going down.
Okay.
Then we move on to the 3p section, which goes up, 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 down, down, down. If you were to progress from there, you would go to your 4s, which also goes up and down. Finally, you get to the d orbital, which, like I said, looks like it's in the 4th, but actually goes down to the 3rd. So after the 4s, we'll go to the 3d, which has 10. So we go 1, 2, 3, 4, 5, and then adding your 5 more to get 10.
That is strange that it goes from 4 to 3D.
And after the 3D, actually, you'll look on your periodic table, and it goes back to 4p, which has 6 in this now. I did that wrong, see. Should have done the up arrow first.
Perfect example of what you shouldn't do.
Exactly. Okay, it then progresses from there. It would go to your 5s, 4d, 5p, and then would progress to the 6s and so on. Okay, now with that would take a lot of writing.
That would.
So let's take, for example, we'll go scandium.
Scandium. Okay.
Scandium is in the 3D level. Okay?
Okay.
So we'll have to go. Instead of doing that, we can go along and see our noble gas.
So you show?
Yep, you can see the closest one to scandium wouldn't be going all the way across to krypton. We would go backwards to argon, which is only 3 elements backwards. So we would really want to lose 3 electrons to get to argon instead of gaining all these to get to krypton. So what we can do is we can write AR in brackets like this. Okay, so AR is in brackets. So that completes the whole electron configuration up to AR, which is our core electrons.
Okay.
Since it's in our noble gas. And after this, we're going to progress from this. We have AR already written. So now we have to write all the way only to here. So we'll write our 4s,
Okay.
4s, and we have those 2 electrons in it, so we'll put the 2 in our complete electron configuration.
Okay.
And then, Santos, what orbital is this?
3D.
Correct. So we'll go down to here and have the SC, and it's the first one in there, so we're only going to have a 1.
1.
So we'll write our 3D.
1.
And that right there is noble gas
Yeah.
configuration for scandium.
Wow. It's like so much more simpler.
Thank you. That concludes our newscast. Have a wonderful day, and we will see you next time.
The end.